In this lecture, we will be covering water tank problems. So we will use modeling with differential equations to solve complicated water tank problems. So we will have two cases. In one case, we will have an amount of water flowing into the tank and a different amount of water flowing out of the tank, which will change the volume of the tank. And in the other case, just like this one in front of us, we will have the same amount of water flowing in and the same amount of water flowing out. So the volume will not change. And these will generate a little different results, but the idea is going to be the same solving these problems. So the idea we start using is rate in minus rate out will be equal to the rate of change, which logically should make sense because if you're having some x rate in, okay, and y rate out, the rate of change will obviously be this will be your rate of change. So it actually logically does make a lot of sense. So we will be working on these problems right here. Now, our problem states that we have 100 gallons of water with 10 pounds of salt dissolved in it. Salt water with concentration 0.2 gallon flows into the tank at 5 gallons per minute. The well-mixed solution leaves out with the same rate, guys, same rate, okay? And we are asked to find the amount of salt in the tank after t minutes. So I will say we are looking for A of t, okay? This is what we're looking for, amount of salt. I will call this A of t. It doesn't matter what you call it. You can call it P of t. Doesn't really matter. It doesn't really concern you. Just be consistent with the naming. And now we know an initial condition is given in the first sentence. So we're not going to deal with that now. We're going to do it later on when we get our A of t function. So what we want to do is solve this A of t function. So the first step we're going to use is find the rate in. Okay, what is the rate in for this tank problem? So we have 0.2 gallons, 0.2, pounds per gallon, okay, flowing in at a rate of 5 gallons per minute. Okay, 5 gallons per minute. So our amount of salt getting into the tank per minute will be 1 pounds per minute. Okay, so every minute you're gonna get 1 pound of salt. That's why we're looking for it. We don't want to deal with gallons because what we're trying to find is the amount of salt. Okay, this is important note. This is important understanding of the concept. So 1 pound of salt is entering the tank. So what is leaving the tank? So from this visual picture, you can see that we are having 1 pound getting into this tank, and this tank does contain some amount of mixture. And we don't know how much mixture we're leaving because the amount of salt in the mixture is unknown. The mixture is we do have some salt in it, and some salt is also entering the tank. So we're not sure what amount of function. It is a changing amount of salt leaving the tank. So we know that the concentration will be A of t divided by 100, which is the amount of volume, the water inside. So this will actually give you how much uh, pounds of salt we have in this mixture. And this is important. And what is the rate we're leaving this amount of salt? And that's just 5 gallons per minute. So these gallons will eventually cancel, and we will have A of t divided by 20 leaving the tank. Okay, this is important. Leaving. This is leaving the tank. So our rate of change will be 1 minus A of t divided by 20 equals to dA over dt. And this, guys, is our very fundamental first order differential equation. And using this differential equation, we will solve for A and then solve the problem. This is basically modeling with differential equations, guys. You just want to be able to form this setup in differential equations, modeling problems, and once you form the setup, you can just solve A using the phi and then that's going to be your solution. So all of these problems are just really, they're just testing you if you could form this, okay? Because the rest is really easy. All you need to do is just solve this differential equation. And now let's analyze this differential equation. Well, we cannot use separable, and the reason is when we use separable, we depend on integration. And we are unable to integrate this because we don't know what a of t is. We need to know what a of t is in order to integrate it, because integrals of different functions do give different results. I mean, if we have a polynomial, our integral will be different than an exponential function or a trig function, so we don't know what kind of function we're dealing with. So you're not going to do integration because we don't know how to integrate a function we have no idea about. So we're going to use integrating factor method. Well, there's two methods to solve these problems. Either you're going to use the separable or integrating factor. And since separable doesn't work, we're going to see if integrating with factor works. And integrating factor does work most of the time. And I mean, most of the time. Sometimes it won't, but in that case, you can use separable. So 1, I'm going to rearrange this differential equation, and let's say a prime plus a over 20. Okay, this is our differential equation. Using separable, we can say that 1 over 20 is going to be our coefficient function, and our integrating factor I of t will be e to the 1 over 20, and this will be integrated dt. So our integrating factor will be I of t over 20. Now we're going to multiply this with both sides, so the left-hand side will be e to the t over 20 equals, and the right-hand side obviously is going to be the product rule. This is from the definition of integrating factor. I'm not going to go over it. We have lectures on it. You should definitely watch it if you're not familiar with this approach. E to the t over 20 times a. This is going to be our format. And then we're going to integrate both sides to solve for a. So integrating the left-hand side will give us e to the t over 20 dt will be 20 e to the t over 20 plus c. Okay, and the right-hand side, if we integrate it, we will just get rid of that d dt from a fundamental theorem of calculus. So our solution will be e to the t over 20 times a equals to 20 e to the t over 20 plus c, just like this. Okay, and after this point, what you want to do is divide both sides with e to the t over 20, and a will be 20 plus c multiplied with e to the t minus t over 20. Okay, I want to write it this way instead of the division symbol. So this right here, guys, is going to be the amount of salt in the tank in any minute. Now what we want to do is solve these constants, this constant c more precisely, and once we solve that, this will eventually be a very specific particular differential equation solution. So from the question, we can see that we contain 100 gallons of water with 10 pounds of salt dissolved in it. This is the very important part. So at the first, what we want to do is A0, okay, will be like initially how much salt do we have, and that's going to be 10 pounds. So initially we have 10 pounds of salt in our system. So we just go ahead and plug that initial condition. So A0 will be 20 plus c times e to the 0 is 0, I mean 1, so we will have c times 1, which is c, and this will be equal to 10. Okay, that means that c is negative 10. Okay, so c is negative 10. So our particular solution for the differential equation will be 20 minus 10 e to the minus t over 20. And another important question is, what does this solution approach to? Well, as t approaches to infinity, what will happen to this equation? Please think about this before you answer. What would happen if t approaches to infinity? Stop this video and think about it. Well, the answer is, as t approaches to infinity, this e to the minus t over 20 will approach to 0, correct? Because we will have 1 over e to the t over 20, and this right here is approaching to infinity, and when you have 1 over infinity will be equal to 0. Okay, so eventually this part of the function will be equal to 0, so this will be approaching to 20. Okay, now this is a very nice problem. We will now do pretty much the same thing, but this is an important problem because notice this. We are water flows in at a rate of 4 gallons and flows out at a rate of 2 gallons in this problem. So our volume is increasing by 2 gallons every minute. Okay, so our volume, I want to start with this. Our volume will be initially 50, but as time t, we will have plus 2t, because every minute we will have 2 more gallons. So as t, if we think about t as a minute, which it is in this problem, every minute we will have more and more 2 gallons of water. Yeah. So, at t equals 0, you know that V0, you have 50 gallons of water. And any time of t, you can find the amount of volume you have containing this tank. So it is important to know this volume change before jumping to the question. And what we're going to do is pretty much the same thing. We will calculate the rate in and rate out, and we're going to subtract rate out from rate in, and then we're going to get our differential equation, solving that, and then we're going to solve this amount of salt problem. So our initially we have 0.1 pounds per gallon of salt, and it flows in with 4 gallons per minute. Okay, 4 gallons over minute, and this means that we're gonna have 0.4 pounds per minute flowing in the tank. Okay, this will be flowing in the tank, and what flows out is 2 gallons. It flows out with 2 gallons, and we don't know how much. It's just a mixture is flowing out. So basically, our A of t is going to be the amount of salt in this problem, and A of t divided by the concentration, and the concentration is 50 gallons plus 2t. This is the volume. So the amount of salt divided by the volume will give you the amount of salt in pounds. And multiplied with what we want to do is multiply this with 2 gallons per minute. Okay, 2 gallons per minute. So what we will have is, I'm going to simplify this, make this expression, and we will have A divided by 25 plus T. Okay, you can just divide this two guys with 2, and simplify it. And this will be our amount of rate out. Okay, this is our rate out. A of T over 25 plus T. Now that we have this, let's subtract the rate in minus rate out. Let's do that. So 0.4 minus A divided by 25 plus T, okay, equals to the rate of change, dA over dt. Now look at this problem. This is now our first order differential equation. We will use integrating factor because I think integrating factor is the only way to solve this, because we don't know this a function. So dA over dt plus a over 25 plus t equals to 0.4. Now let's do integrating factor. Our coefficient of a is 1 over 25 plus t. So e to the integral 1 over 25 plus t dt. Okay, and now you can use u substitution to solve this integral. 25 plus t, let's call this u, and du will be dt. So we will have e to the integral 1 over u du, which is e to the ln of u, and u was 25 plus t, so we will have 25 plus t, and just like this. And now we can cancel these guys, and we will have I equal to 25 plus t, just like this. And let's multiply both sides of the differential equation to solve this initial value problem. So the left hand side will be a multiplied with 25 plus t from the theory of integrating factor. So this will be the derivative, d dt equals 2, and multiplying the left hand side will be 0.4 times 25. I'm gonna write this as 4 divided by 10, or 2 over 5 looks more better. Okay, 2 over 5 divided by, multiplied with 25, and that's just gonna be 10. Okay, so 10 plus 0.4t, or 2 over 5t. Okay, let's keep it fractions to make it easier. So now we're going to integrate both sides, and integrating left-hand side will be, using fundamental theorem of calculus, will be a multiplied with 25 plus t, so 25a plus 25 plus AT equals to, and the left hand side will be two separate integrals, integral of 10 dt plus integral of 2 over 5t dt. So this will be 10t plus 2 over 5 t squared over 2, so just 1 over 5 t squared plus c. And this right here is our solution, and we will have this expression on the left hand side. And now we can pull out this a, so we can solve for a now. So we will have 25 plus t here. And I'm just going to divide this with the left hand side, so we will be able to solve a equals to 10 t plus 1 over 5 t squared plus c, all divided by 25 plus t right here. So this is a really nice expression, and now afterwards we can now just go ahead and plug our initial condition. Our tank contains 50 gallons of pure water. So initially we have 0 pounds of salt in it. So A0 is going to be 0. So if I go ahead and plug 0 for everything, I should find 0. So 0 equals to 10 times 0 is 0, 1 over 0 squared is 0, and c divided by 25 must be equal to 0, so c will be 0 too. So the solution for this differential equation, A, the amount of salt, will be 10t plus 1 over 5t squared divided by 25 plus t. And this is the solution for my differential equation and the problem.